Okay, so let's get started today. We're going to start with our review. So make sure you have your math spiral ready and your pencil. So today we're going to work on two-step word problems, use strategies to fluently multiply and divide within 100, and solve two-step word problems. So we can do this in real life. Okay, so we're going to practice our count bys. We know them all, Finn. So now we just got to keep practicing them, right, Mrs. Harrison? So we do good on that web math minute?
Yes.
We want to pass those fives and say goodbye. And then we'll use the strategies we've talked about for two-step word problems. Not one. How many?
Two.
Lyric, whole body. That means your pencil's down. Thank you. And there's something new we're going to do. It's called a function table. Anybody hear of that before? You may have done those in second grade with addition and subtraction. I bet you did. But this one is going to be probably focusing more on it, multiplication and division. It's called a function table. So we'll get something new today. Yay. All right, let's go ahead. We're going to review this addition. And then I'm very anxious to start subtraction because I noticed today when we did something central this morning that we forgot how to subtract. So I might throw one subtraction in here at the end if we have time, just to remind you of what you learned in second grade for subtraction as well. Anybody at home willing to do the first one for us? 678 plus 124. I'm looking for hands from my remote learners. It is a little intimidating. Ben, you are going to accept the challenge. Please unmute and walk me through it.
So at the very end, you put like 8 plus 4 equals 12. So you put the 2 at the bottom, the 1 at the top of the 7. So that equals 8. So that equals 10. Then you put the 0 at the bottom of the 7 and 2. Then, since it was a 1, 7 plus. Then, since you put a 1 on top of the 6 equals 7, then one more equals 8. So it equals 802.
Okay, I am trying to get my smart ink ready while you explained that. So hopefully, now that I got out of that, that will come back. So he said that we're going to add the 8. Oh, goodness. Okay. The 8 plus the 4 and get 12. And it's not letting me write on it right now. So I'm going to exit out. I love how you made new groups, Ben. Exactly. And I'm going to exit out for just a minute and see if it'll let me write on it now. I think my smart ink, because I use the smart board for something else, is acting up now. It is. So we'll refresh. It's saying it's not connected. Okay. Have to keep. Yay, now it's going to let me. All right. Yay. So let's go back to present mode. All right. Give me 1 sec, Ben. Your patience is a virtue. So my mom always said, patience is a virtue. Yay. Now it's going to like me. Okay. So if you did not hear Ben, just kidding, right? 8 plus 4 is 12. He started. Holy moly. All right. Think. Yeah.
Oh, there you go.
It does not want to work. He's gonna have to do the whole thing like this. Are you freaking kidding me? Yeah, maybe I can figure it out. It's because I was using Smartboard for an activity. Here, just write on it right now and see if it works. Yeah, no. So do you want me to go to my tools real quick? Let's just.
So last time I fixed it, I turned off something.
Right.
I turned off something and then I turned it back on and then it worked. Yeah. So, down to the bottom, of course, because it's super off. Okay, Smart Ink. The last so what did I do last time? I turned it off for a second. So see that right there? Unclick it. Right. Now try to click it again. So last time I turned it off entirely. Dude, I turned something off entirely and started over again. I don't know what I did though. I'm trying to think it wasn't there. It was someplace else.
Somehow I got out of that. All right, guys, I'm trying to fix my Google slide. It's not working very well. Now nothing. Now it won't let me. My computer's just frozen because of the Smart Ink. Okay.
Good. Oh yeah.
I saw that I did something.
Let me go check.
I would see it. All right, guys, let's keep your fingers crossed and hope this one's going to work. All right, so we're going to have to go to the document camera. Sorry, guys. I'm going to write these down on my paper. You guys can write them down too. So let's start with the one Ben said. He was absolutely right. 8 plus 4 is 12. You don't put the 12 in the ones place because look what that would look like. That doesn't make sense. Make sure you take that 1 and put it in a new group for your tens. Then don't forget to add it in. That's one of the biggest mistakes we make as mathematicians. We forget to add it in. So 7 plus 1 is 8, plus 2 is 10. Put the 0, carry the 1. Add the 1, the 6, and the 1. 6, 7, 8. So good job, Ben. Give him a thumbs up if you agree with him. The next one is 479 plus 144. Anybody at home willing to give it a shot? Be brave. You can do it. I'm looking for volunteers. Yay, Haley. Okay, Haley, can you unmute?
Okay, so for 9 plus 4 equals 13. So you put the 3 down and then carry the 1.
Awesome sauce.
And then 7 plus 4 equals 11 plus 1 equals 12. So put the 2 down and carry the 1. And then 5 plus 1 equals 6. So 623.
And you didn't even say and. Well done. She did not forget the 1. She added it to the 4 to get 5. Okay, the next one is 351 plus 876. Wow, this is going to be a big number. All right, Max. And what would I get if I added 1 plus 6? 7 and then equals, okay. Am I done? What's that called? Anyone know what that's called, that symbol? August? No? What do you think? A comma. The comma is your thousands place. Let's read that number together. Ready? 1,227. Well done. Okay, the next one is 907 plus 256. And you guys are so good at this. I am going to throw a double-digit subtraction in after. All right, Henrik, what do you think? And what is 7 plus 6? So what do I need to do? And what'd you get? Am I done? Don't forget the comma. All right, give a thumbs up if you are feeling good about 3-digit addition. Sideways if you think we need more practice. Down if you are really struggling. Katie, how are you feeling? Up? Good to see. Wow. Let's see if my other friends at home. Reese, Lila, Gavin, how about you, buddy? Keppel. Okay, Robert. Paxton's feeling good. Hi, Paxton. How about here? Thermometer, real quick, just on addition. I would say overall we're looking good. Let's try double-digit subtraction. Here's what I want you to do. Let's do 74 minus 28. And let me tell you what I'm noticing. August, I see people are subtracting from the bottom up, and you can't do that. It's impossible. So Sawyer, do you know, is he okay? Yeah. Okay. Sawyer, do you know what I should do to figure this problem out, 74 minus 28? All right, let's think about this. Let's do it the same way, starting in the ones place. But of course, now we're subtracting. Can I take 8 away from 4? Marin, what do you think? If I have 4 apples, can I give you 8 apples?
No.
Yeah, it's not enough, right? Okay, so you can't say 4 minus 8. You have to knock on the door and say, can I borrow a 10 and take a 10 away from the 10s? And now you're trading one of those 10s to make it 10 ones. So now I have 14 minus 8. Can I do that? Paxton, can I do 14 minus 8? Thumbs up, he says yes. Marin, do you know the answer?
6.
She says 14 minus 8 is 6. So how did you get that answer? When you subtracted, what strategy did you use?
I counted from 8 to 14.
So that is a very good strategy. You count up from the lower number to the high number to find the difference. Let's do it. 8 in your head, 9, 10, 11, 12, 13, 14. What did we get?
6.
Awesome. Now, 6 minus 2. Put up your 6 fingers. Take 2 6 fingers, take 2 away. What do we get, Robert?
54. Wait.
Yeah, 6 minus 2 is 4. So you would get 46. Let's try one more. Let's do 62 minus 55. Using the same strategy, start in the ones place. Can I do 2 minus 5, Bird? No. If the number in the ones place, Cooper, on top, please listen, put that down, listen. If the number on top is smaller than the number you're subtracting, you can't do it. Okay, that's what I saw a lot of people doing. They would just say 5 minus 2 is 3, 6 minus 5 is 1. That's not right. Don't do that. Make sure the number on top is bigger than the number you're subtracting. So knock. Hey, I don't have enough ones here to subtract 5, right, Haley? Don't have them do that. I'm going to borrow from you. So you take 1 away from the tens. Look up here instead of there. Look up here. And then you're going to put that 10 in the ones place. Can I do 12 minus 5? Sure. Let's count up like Marin suggested. 5 in our head. 6, 7, 8. Show me. 9. Show me, Lyric. 10, 11, 12. What did we get? 7. And then 5 minus 5 is nothing. Do we put a big 0 there? No, because if you're writing the number 7, you're not going to have a 0 there anyways, would you? Okay, I know we're going to, as third graders, we need to do triple digit subtraction. I just wanted to show you the double to start with. We'll work on that more because that is something you learned in 2nd grade. That's just a quick review for you. All right, since my smartboard's not interacting with my ink, I will flip back and forth between my dock cameras. So thank you for your patience. Oh, not what I wanted. How did that happen? Okay, so we're gonna get in present. Why is it doing that? Today is my test day.
Deep breaths, Mr. Robin, deep breaths.
Or cross your fingers for me so my slides. I think my computer's overused. It's not even, it won't even click. Okay.
That's okay. Earlier today, Mrs. Harrison was overused.
Yours. You know what? Maybe if I go to the classroom, it'll let me pull it up that way. Oh, see, the smart thing is really doing weird things. It works when I don't want it to.
I almost feel like you have to like, is there some way to turn it off and on?
I think I need to get out of my computer and start all over, but I'm not going to. Is everybody crossing? Are you guys crossing your fingers? All right. I'll know if you're crossing your fingers because it'll work. Okay, I think you guys must have crossed your fingers. It looks like it's going to let me do something. All right, part of our learning target was not only about function tables, it was about 2-step word problems. We have graduated from 1-step to 2-step. We are still reading the problem carefully. We are visualizing, retelling, interpreting clues, modeling the relationship, finding the unknown, and reflecting. I think that reflection piece is the most important, but you guys know that. So before we turn to our, let's look at the different things you guys came up with. So Elena, what do we know about word problems that require multiplication? So when we are looking for clues in our word problems, you don't know the total. You're trying to find a total. It's repeated addition. You usually have equal groups. Sometimes it'll be rows and columns, like in an array. So that is one of the things we can look for. Those are some of the clues. How about Sawyer? What are some of the characteristics or clues for division? Division. You know the total. What else? We're putting things into equal groups. You got to visualize that. Most of the word problems we've had lately actually say divided. And that is the big clue, right? And what else, my dear? It's equal shares. You're dividing it up. Addition, Finn, what are the characteristics of addition? So the difference between multiplication and addition, both of them you're looking for a total. You don't know it. But with addition, you're doing it with different numbers. It's not the same group again and again and again. Right, guys? All right, August, what about subtraction? Lennox, can I have whole body listening? Thanks, buddy. What about subtraction? No more of that. You do know the total. You know your amount. Okay, you can use addition to help you because it's the inverse operation. Very good. But you're doing what? You're taking something away. It's like spent, bought, gave away. You ate it. Yesterday, we were drinking ounces of water. All right, let's practice. Let's turn to page 145. Awesome. We're going to look in your math workbook. Turn to page 145. Get your pencil. Marin, do you have it? You ready? Oh, you don't have it. You'll have to use a pencil and paper. Sorry, I forgot. All right. Raul spent 10 minutes doing homework for each of 5 subjects and 15 minutes for another subject. How many minutes did Raul spend on his homework? I want you to try this without me for a minute. See if you can figure this out, and then we'll go over it. I'm going to give you a minute or two. Think about the strategies we've talked about and see how you do.
Right. I was gonna see if I could figure it out.
Hi. Go quick.
I know. Well, that's how, every once in a while mine turns upside down. So I have a little piece of, and literally, like the whole screen is upside down. And I have the order of what I have to do to fix it. Now, what number do I do to get it that way?
And you couldn't do it if you wanted to.
Do you have your answer? Yeah. Start working. At least you have alternatives. I mean, you gotta get your brain around it. You forget. At least you have paper. Yeah. Do you have it? Well, read the whole thing. Raul will spend 10 minutes doing homework for each of 5 subjects. So your question is what? How many minutes do you spend on those 5 subjects? 10 minutes for each of 5.
All right, I'm switching over to my dock camera because it's still being funny. So I'm just curious if you guys figured out where to put the line, where the first step would end, where your mind should be asking a question. Does anyone know where I should draw a line to separate my first step from my second step? What do you think, Madison? After 5 subjects. If you did that, you were right. That is where my brain is wondering, how many minutes did Raul spend doing his homework for his 5 subjects? So in parentheses, how would I find the answer to how many minutes he spent doing homework for 5 subjects. Any ideas? Any ideas out there? How about Charlie? Okay, so I'm not dividing anything up into equal shares because I don't know a total. Do I know the total? I'm looking for a total. But I have repeated addition because I have 10. I have another 10 for the next subject, another 10 for the next subject, another 10 for the next subject, and another 10. You need to multiply, right? Equal groups. So 10 times 5 is what? So if I have 50 minutes total and 15 I have to add 15. So now over here I can stack on. You not need to. That's exactly. Wow, how did you do that? Thank you. 0 plus 5 is 5, and then go to your tens place. 5 plus 1, Evie, is what? Evie, what's 5 plus 1? Turn around, honey, so I can help her out. 5 plus 1. 6. So what is our answer? And what's our unit? Minutes. 65 minutes. All right, let's look at number 2. At Sonia's cello recital, there were 8 rows of chairs with 6 chairs in each row. There was a person in each chair, and there were 17 more people standing. How many people were in the audience all together? All right, Mr. Gavin, can you tell me where I should draw that line, where my brain would be asking a how many question for our first step? What do I need to know first before I can find out how many people were in the audience all together? Gavin, can you hear me, honey? There you go. I'm looking for you. Was he there the last time you were? Yeah. Okay, he's not there. Okay, Lila, let's have you unmute.
I split it after it said with 6 chairs in each row.
Excellent. And what are you wondering? How many chairs what?
I'm wondering how many people sat in each row.
Well, we already know
and
that.
how many people
There's
were
6.
together.
What do we need to find out? If
We need to find out the total of all the people in the audience.
how many chairs there are all together. So if I have 8 rows with 6 chairs in each, Max, what would I do to find that out? You have 8 rows, 6 chairs in each. Sawyer, be thinking. Max is going to help us. 8 groups of 6. It's repeated addition. We don't know the total. And the nice thing is, we know 6 and 8 went on a date. They didn't come back till they were 48. So am I finished, Gavin? No, what do I do next? There was a person in each chair, and that's the 48 chairs we just figured out. And there were 17 more people standing. How many people were in the audience altogether? Can you unmute and tell me what I should do next?
You should multiply 8 and 6.
So we already did that, but what's the next step, buddy? There was a person in each chair, so we know there's 48 chairs. And there were 17 more people. Besides the people sitting in those chairs, we have 17 more standing. We want to know how many people were in the audience all together. That's a key word for you. What should we do?
Then you should multiply. Then you should multiply 17 and a total of 8 and 6.
Okay, the problem is, you're right that we don't know the total, but we don't have an equal group. We don't have repeated addition. We only have to add one number. So what should we do? You're just adding 17, Gavin, because look, we already multiplied. We had 8 rows of 6. But now it's just saying there were 17 more people than that. Not equal groups, not a repeated amount. So we definitely don't want to multiply. That would be a hard problem to solve, wouldn't it? 48 times 17? If you get a big problem like that I haven't taught you how to do, you might want to check your work and see, maybe I misunderstood that. So we're going to add that. Go ahead and in that column where it says show your work, stack your numbers. Start in the ones place. This is exactly what we started with in our warm-up. Josh, walk me through it. What's 8 plus 7? 145? See on the right one? Okay, what do I do with the 10? The tens place? All right, so you added the 1 and the 4 and got 5 and added 1 more and got 6. So we get 65, and what's our unit? What are we talking about? People. All right, we're going to do one more together, then you're going to do the last 2 with the partner. Jana played a game with a deck of cards. She placed the cards on the floor in 3 rows of 10. Okay, so think about that. Try visualizing that. In the deck, if the deck has 52 cards, how many cards did Jana leave out? Okay, you got 3 rows of 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's my 3 rows of 10. Where am I gonna put that line where I'm gonna ask a question before I figure out the final question about how many cards she left out? Where's that first step question gonna go? Where do you think, Ellie? Right here. What do I want to know, Ellie? If Jana played a game with a deck of cards and she placed the cards on the floor in 3 rows of 10, I'm wanting to know how many what? How many cards in all? Look at the picture I drew. What do you see? Is that going to be multiplication, division, addition, or subtraction? Ellie says multiplication. Give me a thumbs up if you agree with her. Why do you agree, Lucas? What do you know about this that tells you it's going to be multiplication? We don't know how many cards there are in all. We don't know the total. Why am I going to use multiplication instead of addition? Which you could do addition, but repeated addition, multiples of 10. So we can go ahead, and what's the equation going to be? Three rows of 10. Put that in parentheses. It's your first step, which is 30. Now, if the deck has 52 total, but she only put 30 down on the floor, how many did she leave out? How am I going to figure that out? Show me on your fingers. Am I going to multiply, divide, add, or subtract to find out how many are left in the deck? Show me with your fingers. Hold it up. I don't see your thinking. Am I gonna, what do you think? There's 52 cards. She set 30 of them down on the floor. How many did she not sit down on the floor? How many did she leave out? Really think about it. August, what do you think? Why is it subtraction? Can you explain why we would subtract? You're right, Bud, but why? Let's just think about this. What if I added 30 plus 52 and I got 82? Would that make sense? Jana played a game with a deck of cards. She placed the cards on the floor in 3 rows of 10, which is 30. If the deck has 52 cards, she has 82 that she left out. Would that make sense? That's impossible. She only has 52. How could that be? So we wouldn't add. Were we dividing? No, we didn't put anything into equal groups. We didn't say we had rows and columns when we, for the second step. We said if it has 52 cards, how many cards did Jana leave out? Yes. It is subtraction, yes. So can you walk me through this, Charlie? What's 2 minus 0? What's 5 minus 3? 5 minus 3, microphone answer? So we should have gotten 22 cards. So look for those clues, reflect. Now if I reflect and say, Jana played a game with a deck of cards. She placed the cards on the floor in 3 rows of 10, which is 30 cards total. If the deck has 52 cards, she left out 22 cards. Does that make sense if I reflect? Yes or no? Yeah, makes more sense. All right. Mukesh is the name. Mukesh, you are going to work on the next 2 with a partner. You're going to be in breakout rooms. We'll give you maybe 6, 7 minutes and we'll check back in with you. Good luck, mathematicians. Use your strategies. Don't forget to reflect. All right, guys, take your hair out and do your math. We're not here about hair, right? We're here about math. Get started.
Oh, Mrs. Ahmed, you're the host.
I am.
You are. I can't put them in breakout room.
How did that happen?
I don't know.
Okay.
I have to like.
That's so weird. I can never be the host, I feel like. Join your breakout room, Lila. Join your breakout room, sweetie.
Okay, but it ran away from me.
Join your breakout rooms. Why does it say all breakout rooms will close?
Oh, you double click.
Shoot.
Sorry.
At least we know.
Yes.
So just start over.
That's exactly what I did the other day when they all went, when they all came back.
Oh boy.
Just so you know, I have to stay at 12:45 during my OT lesson. I could
Oh, same thing.
So if you hit, yeah, and as soon as it hits, whenever it hits, like when it hits 0, you can do the thing and say create rooms again, and then you have to say open, you have to say open all rooms, so they'll come back in this. There you go.
And act like that's a camp.
Well, you know. Because the explanation's gonna take longer than that.
All right, I'm gonna pop. Do you want to do that, or do you want to do
Well, I'm
this?
worried I'm gonna,
You might not be able to get
I
in.
might not be.
I don't think you will. Are you? Can I just use you? Well, I might be able to hear him. I'll just try.
You can get in and out, but I'll do that.
Clara, can you join your room, honey? Ben, is it allowing you to join?
It says
Just here to listen in. Somebody want to read the problem so you guys can share your thinking? Hey guys, who wants to read the problem so you guys can share for number 4? It's Makesh. Somebody needs to read. Makesh was making, you're supposed to work together and talk, right? Okay, I'm gonna leave. I want you guys to talk to each other, and then I'm gonna pop back in, and I hope I hear voices.
So then let's figure out the problem for it.
Okay, cool.
Hoping it's.
why I'm forgetting it and I am going everywhere. I'm so
Sure, let's go back and look at this, okay?
You guys sharing your thinking? That was not.
I guess. I don't know.
What'd you get for the
We are.
4?
We got 7 times 6, and we're figuring out the answer right now.
So you got the first step. Now you got to figure out the second step.
Yeah.
What are you going to do to figure out the second step?
I'm gonna do the number of 6 times 7 divided by, divided by 51. Divided. Well, we.
Do you guys agree with that?
No, I don't. Because you cannot divide 42 by 51.
Good thinking, Robert. What might you do instead? Okay, be thinking. Be thinking.
You're muted. You're muted.
All right. All right, Mukesh was making 7 salads. He opened a can of olives and put 6 olives on each salad. You should have put a line here and thought, okay, if I have 7 salads and I have 6 olives on each one, Haley, don't do it. Look up here, please. I see that I've got 6, 7 times. That's repeated addition, which means I'm going to multiply. I don't know how many olives there are all together. I need to find that out first. So give me sparkles if you got 7 times 6 for your first step. All right. I know 7 times 6 is 42. But then he ate the rest of the olives in the can. If there were 51 olives to start with, how many olives did Mukesh eat? 2 of 51 were on salads. The rest he ate. How many did he eat? You when I make out room. Do you come up with your answer? What's the sound? Can I hear this?
Yes, I did.
Okay, how many came up with? What did you do to find out how many else Mukesh ate?
I did minus 2, and I think I know the answer.
So let's do it. Everybody in your workbook, because this, I don't know, Mrs. Harrison, I don't think they got this. Most people did not. No. If you added, then I know you did not reflect. Because if I would add these, I get 93. Could Finn? Would that make sense? Most making 7 salads. He went to campus and put 6 olives on each salad. And he ate the olives again. We know there's 42 on salads. There's 1 to start with. Could be 93. Or you open the pencil sharpener. Now, you're not even on the page. Get on 145, please. And listen. Could we have eaten 93 olives? Yes or no? There's no possible way. He only had 51. So, Robert, you were right. You had to subtract. Count 1, 2. Yeah, 2. You got to 4. Bring that 10 over. Can I do 11 minus 2? Yeah. Count backwards. 11 in your head. 10, 9. And 4 minus 4, 0. What should we have gotten? 9 olives. If I reflect and put that answer back in my problem, 9 olives makes sense. He could have eaten 9 olives if 42 of them were on the salads and he had 51 total. That makes sense, right, Max and Lennox and Finn? But does that make more sense? For sure. All right, Peter wallpapered a wall that was 8 feet wide and 9 feet high. he had 28 square feet of wallpaper left over. How many square feet of wallpaper did he start with? I hear an area problem. Cooper, what did you and your partner do?
I know.
Okay, did anybody get to it? That would be one. You're right, because you want to know, well, you don't know all my mind. What is the area of that? How many square feet is that? So 72, and what do you do with 72? So if I add, I'm gonna reflect. That's gonna be 100. So if Peter wallpapered a wall that was 8 by 9, which is 72 square feet, and he had 28 square feet left, how many square feet of wallpaper did he start with? Would that make sense? Would it? Okay. So put it in there. How am I going to add that up? Can you do that for me? What is 2 plus 8, Miss Elena? 10. Put the 1 in the tens place. 1 plus 7 plus 2? Would be 10, and now I've got 100. Okay, perfect. And that's going to help you every time, because these are tricky. Because it's left over. This is going to make you think what? Minus how? Well, you don't have to tell me. Okay. Wow, our day is going super fast. I had one more thing to zip through, and it's just more to kind of teach you what a function table is. We'll keep persevering with those word problems. One other thing I wanted to show you is what a function table is all about. So just watch and listen. And I don't know if it'll remind you of second grade, but maybe.
Now available ad-free and child-safe at numberus.com. In support of distance learning, we're offering a 30-day free trial for all new members. Let's rock it.
That what? No, this is not what we want. That's not what I had. Sorry, guys. Hold on. How did it get to that? You saw the functions, right? Okay, let's try again. Input. Oh, it's not letting me do it. Okay. Yep, I'll just. Yeah, we'll do that when it's fraction time. How about that? There it is. It is. It's like there's a ghost. This is a fun way of thinking about it. So pay attention.
Going up to fly. The table shows our time and hide in the sky. 1 minute we're 3 meters off the ground. At 2 minutes we're 6 meters up. Staring down. At 3 minutes we're up 9 meters high. What's the rule that shows our place in the sky?
This will make sense in a minute.
If we multiply any input by 3, we get the output. So that's the rule, you see. In goes 4, out comes 12. In goes 5, out comes 15, 12. In goes 6, out comes 18. The rule is times 3, and the view is first thing. What's happening between the in and the out? We can always find out without any doubt. Make an educated guess and test it out. Till you find what the rule is all about. I have a function machine, the best you've ever seen. I put in a 9 and out came a 3. I put in 15 and out came 5. Then 27 went in and out came 9. There's only one thing I want to know at this junction. What on earth is my machine's function? If you divide any input by 3, you get the output. So that's the rule, you see. In goes 6, out comes 2 for sure. In goes 12, and you know I will come 4. The simple output table has a rule. It's divide by 3.
All right, so I think it'll make more sense when you see page 146. Page 146 in your math workbook has function tables. So you will see it tells you the definition. We're just going to do 2 of these. Is that okay, Mrs. Harrison?
Yeah, they have to go to the numbers.
Oh, yay, thank you.
Yeah.
All right.
I just wanted them to see what.
Yeah, and I can work with them again. So it's page 146. We'll do a couple. I'm just thinking you might see these and think central. It's just a fun way to practice your multiplication and division facts in any actually operation. But we're looking at multiplication and division on these. So a function table is a table of ordered pairs. For every input number, there's only one output number. The rule actually describes what to do to the input number to get the output. So I need to figure out 7, what do I gotta do to 7 to get 42? Because I have 2 missing lines here, I'm gonna look at the 2 pairs that I can figure out. What do I have to do to 6 to get 36? I have to multiply it by 6. So I know 6 times 6 is 36. And then I can check it up here. 7 times 6 is 40. What's 8 times 6? 6 and 8 back till they were 48. But what am I going to do if I have the output number and I'm trying to find the input number? Max? You divide. You think 9. Okay, one more. 1 to get 9. What do you think I'm going to multiply them? What are you thinking, Madison? This time I have to divide. 9. Wow, you guys are quick. So 81 divided by 9 equals 9. 45 divided by 9 equals 5. What's 72 divided by 9? Uh-oh, but I need to figure this out. I can't do 7 divided by 9. However, what could I do to input number? Instead of doing 7 divided by 9, what could I do? To find the input number.
I forgot.
Okay, well, let's think about it. If over here, I knew it was 9 times 6. When I got to 54, I divided. I did the inverse. So what is 9? That equal my answer. 63. So that is a fun way to practice your facts. It's called a function table. Did you guys remember the 2nd grade? Max does? Oh, you did? Awesome. I see some hands. Some people remember from 2nd grade. Okay, guys, you guys have a great rest of your evening. You can work on those and finish them up. We will see you tomorrow. Great work today, mathematicians.